mappings here, they can be written in a function notation. When I talk of function notation, if I have f of x is given by x squared plus 2, that is my function notation. That f into brackets is read as f of x, which is defined by x squared plus 2. Then in this case, you are required to find the range values if they give you the following x values. If they say where x, then they give you 1, 2, 3, and maybe 4, like that. So they want us to determine the elements of the range if we have this function given. This is a function notation, and so they've given us that this function f of x is defined as x squared plus 1. Then they've given us the x values. So we shall basically treat these x values as our domain elements, and then we use the formula, or we use the expression for the function of f of x to get the range values. What am I meaning? Now, we shall first of all have our arrow diagram, this format here, like that. Then here we shall have the domain part, and then we shall have this side, the range part. So this is the range or output values. The side of the domain, we shall put there the x values as described in the function. We have 1, we have 2, we have 3, and we have 4. But not forgetting that f of x here, it is defined by x squared plus 2. That means if this is f of x, then these are the x values given 1, 2, 3, 4. These ones that are given. Then they want us to get the range values with the use of this formula x squared plus 1. So under this, we shall just have a simple calculation just down here, and we get the values for the range. So to begin with, I will just write the function that f of x is equal to x squared plus 2. Just do this by you replacing this arrow with just equal signs. Now, what if f of x is defined by that? So we can now take x to be 1 as our first x. We test for 2, for 3, and 4, and even other values if n. So that means if f of x is equal to that, then f of 1 equals, where I have x, I'm just going to substitute it with the value 1, which will be 1, but it is squared here, so plus a 2. So my f of 1 here will be equal to 1 squared, which is a 1, so plus a 2, and finally we get a 3. So our f of x, and when x is 1, then we have the value as a 3. So that 3, I come and put it there, then you put the arrow that this one goes with a 3. In the same sense, we also test for 2. So our f of 2 will now be equal to 2 squared plus a 2. And when you simplify that, you have a 6. You still put a 6 here. Still, you test for f of 3, which is 3 squared plus a 2. And then this gives us 11, because this 3 squared is a 9 plus a 2. That is 11. You still do the same. This is 11. And finally, we can test now for f of 4, which is equal to 4 squared plus a 2, giving us 18. So 4 squared is 16 plus a 2, that is 18. So we have now illustrated our function f of x using an arrow diagram. It is called an arrow diagram because it has the arrow pointing towards the range value. This arrow shouldn't be reversed in any way whatsoever to point this side. It is the domain values that are giving us the range, or the input giving us the output. Actually, you can call this domain part, can call it input values, then we call this output. Why is it called input? Because we've been using these input values 1, 2, 3 up to 4, and now they have given us these outputs. So this side qualifies to be called the input side, and then the other side qualifies to be the output side. In case required to write the set or the elements of the domain, you simply come here and say the main values, then you open a bracket and you write them 1, 2, 3, and 4. You close the bracket. In the same sense, if you are required to write the range values, so the range will also come here and say you have 3, 6, 11, and 18. You also close the bracket. In some cases, you can be required to write the type of mapping shown above. The type of mapping depends on how you are seeing it. We are saying that one member of the domain only shares one member in the range. So that means among the types of mappings that we have, a list of them, many to many, many to one, one to many, and one to one, you see that this is a one-to-one type of mapping. So be in a know of how to tell the type of mapping just by mere seeing. If you see that one member in the domain is only having only and only one member in the range part, so that is a one-to-one type of mapping. Now, from here, I want to look at another important term, and that is none other than functions. Functions, still under mappings.